Hey everyone, this is Group 1. This time we are going to discuss about thermal equilibrium. When two objects are in thermal contact, the temperature of the hot object will drop while the temperature of the cold object will rise until the temperature of both objects become the same. Net heat transfer between the two objects becomes zero. Hence, both objects are said to be thermal equilibrium. The diagram below shows a hot object P and a cold object Q. Hot object P is in thermal contact with cold object Q. The rate of heat transfer from P to Q is higher than the rate of heat transfer from Q to P. Now, let's do a quick revision. In Form 2, we have learned about heat. It states that heat energy is transferred from a hotter region to a colder region. Therefore, the rate of heat transfer from P to Q is higher. Back to the topic. There is a net transfer of heat from P to Q. Therefore, temperature of P drops and temperature of Q rises. Finally, temperature of P and temperature of Q become the same. The rate of heat transfer from P to Q is same as the rate of heat transfer from Q to P. Net heat transfer between P and Q becomes zero. P and Q are in a state of thermal equilibrium. Now, let's talk about thermal equilibrium in daily life. We will use the concept of thermal equilibrium in heating an object as well as cooling an object. For example, the clinical thermometer is placed under the tongue of the patient to measure the body temperature. It flows from the body to the thermometer until thermal equilibrium occurs. When baking a cake, heat is transferred from the hot air in the oven to the dough until there is a thermal equilibrium between the dough and the air in the oven. For cooling an object, when food is stored in the refrigerator, heat from the food flows to the air in the refrigerator until thermal equilibrium occurs. In this way, the food stays fresh for a longer time as the temperature of the food has decreased. Besides that, the drink is cooled down by adding a few pieces of ice. Heat from the drink is transferred to the ice until thermal equilibrium is achieved.
Let's discuss about calibration of a liquid in glass thermometer using two fixed points. First, what is calibration? Calibration is the process of making the scale on a thermometer to measure temperature. The temperature 0 degrees Celsius is the lower fixed point and the temperature 100 degrees Celsius is the upper fixed point. Then the length of the liquid column between the lower fixed point and upper fixed point is divided into 100 equal divisions. Thus, thermometer is calibrated and can be used to measure temperatures between 0 degrees Celsius and 100 degrees Celsius. This is an example question of calibration of thermometer. Aisha uses an uncalibrated laboratory thermometer to determine the temperature of a liquid. Theta degrees Celsius, she finds that the length of the liquid column when the thermometer is put into the liquid is as shown in figure 4.6. Calculate the temperature of the liquid theta degrees Celsius. Firstly, from figure 4.6, we know that the length from the 0 degrees Celsius mark to 100 degrees Celsius, L100 is 12 centimeters, and the length for the 0 degrees Celsius mark to the theta degrees Celsius, L theta is 4 centimeters. Then use formula theta equals to L theta over 100 times 100 degrees Celsius. After doing the calculation, theta is equal to 33.33 degrees Celsius. That's all. Thanks for watching.